Okay, so look at this example. Now for the part A, a concave spherical mirror forms an inverted image, the 4 times larger than the object. Assuming the distance between the object and the image is 0.6 meter, find the focal length of the mirror. Okay, so now we have the concave spherical mirror. Okay, and then we have the inverted image 4 times larger than the object. So now from this sentence, right, let's look at the picture. Okay, we have the inverted image 4 times larger than the object. So it means that the image is larger than the object, right? We have the 2 types of the image here for the concave mirror, that the image is larger than the object. But now I say that the image is inverted. Okay, if the image is inverted, it means that it's going to be in this case where the object is between the focal point and the center of the curvature. Okay, so let me copy these pictures. Okay, so now from this sentence we can say that the object, okay, is between the center of the curvature and the focal point. Okay, so that's why we can just use this picture here. Oops. Okay, let me make it smaller. Okay, good. Okay, so assume that the distance between the object and the image is the 0.6 meter. Okay, so here let's say that we have this one to be the object distance, right? We use a symbol as equal to the s. And now here, the image distance, we use the symbol as the s palm. Okay, the s palm. So then from this sentence, right, so the distance between the object and the image is the 0.6 meter from this sentence. Okay. Then we can say that because in this case the s palm is positive. Okay, the s palm is positive because the image is on the same side as the reflected ray, right? The s palm is positive and the image is the real image, and the s is positive as well because the object is on the same side as the incident light ray. Okay, it means that the s palm minus s equal to 0.600 meter. Okay, s palm minus s equal to the 0.600 meter here. Okay, so next, the inverted image, right, is 4 times larger than the object. So it means that we have minus s palm and then over the s, it just equal to minus 4.00. Okay, because the image is inverted. Okay, for the inverted image, so the magnification must be negative, equal to the minus 4.00. Okay, this is the lateral magnification here. Okay, so don't forget that this negative sign just come from the object, the image is inverted, right? So we say that if we have the inverted image, the m must be negative. Okay, so now we just want to solve for the focal length, right? To find the focal length, we can use this equation for the f. Okay, but the problem is we don't know the s and we don't know the s palm. Okay, so the first of all, we need to find the s and the s palm. Okay, but then how can we find the s and the s palm? So we can find both of them from these two equations. Okay, we can find both of them from these two equations. Okay, so let's just start. Find the S and the S prime. Okay. Okay, so let's say that from this equation, okay, we have the S prime equal to the 4.00 times the S, right? From this equation, so the negative side just cancel out, and we have the S prime equal to 4.00 times the S. And then if we plug in this into this equation, we can have that the 4.00 times the S minus the S equal to the 0.600 meter. Okay, so then finally we can just solve for the S. So then the S here is going to be equal to, okay, this will be the 3S, right, and 3 to here. We have 0.200 meter for the S, and also we can get the S prime to be, okay, let's do this one. So we just multiply the S by 4 here. We have 0.800 meter for the S prime. Okay, then so let's find the focal length F. Okay, let's find the focal length F. Let's use this equation, the 1 over the S and then plus the 1 over the S prime equal to the 1 over the focal length F. Okay, let's use this one. 1 over the S, okay, the S just the 0.200 plus the 1 over the S prime, right, just 0.800, and then equal to the 1 over the F. Okay, so this, be careful. From my experience, some of my students just do the via algebra here. Okay, for example, if you just want to find the F, right, I mean sometimes they just do something like 1 over 0.2 plus 0.8. Is it correct? No, right? It's just wrong. Okay, so don't do something like this. Then you need to have the same denominator, right? Let me just switch. Oops. Okay, so then equal to, so we just want to have the same denominator. This is 0.8 and this is 0.2. So let me multiply the first term by 4 to be the 0.8. So we have the 4 plus the 1, okay, and then over the 0.800, right, which is equal to 5 over 0.800. So then finally we can get that the focal length, okay, of this concave mirror here equal to the 0.160 meter, and this is going to be answers. Okay, one thing that you can check is the focal length is positive, right? The focal length is positive, so we say that if the focal length is positive, right, it means that we will have the real focal point. Okay, it means that this focal point is on the same side as the reflected ray for the mirror. Okay, so let's check. We have the focal point here, okay, and which is on the left hand side of the mirror, and the reflected ray is on the left hand side of the mirror as well. It means that the focal point and the reflected ray are on the same side of the mirror. Okay, so that's why the focal length must be positive. So now for the part B. Okay, what if suppose the mirror is convex? Okay, so don't forget that we have only one type of the image for the convex mirror. The distance between the image and the object is the same as in the part A, which is equal to 0.6 meter. right? But the image is 0.5 the size of the object. So this means the focal length of the mirror. Okay, let me copy the picture first. Okay, here. So we say that, right, the distance between the object and the image is equal to 0.6 meter. So in this case, it's going to be this distance. Okay, this is the object and the image, right? So here equal to the 0.600 meter. Okay, so let's just write down as equation. We have okay, this is the S, the image distance. Okay, sorry, the object distance, and this is the S palm, the image distance. But don't forget that for the convex mirror, the S palm is negative, right? The S palm is negative. But we know that the magnitude of the S plus the magnitude of the S palm equal to the 0.6 meter. Okay, so I say the magnitude. So we just take only the number, not the sign. Okay. So if we just want to write down as equation, we can have that the S minus the S palm equal to the 0.600 meter. Okay, don't forget that the S palm here is negative, right? S palm is negative, so negative, and we have this negative sign here, so it's going to be the positive, right? So that's why we can just sum up the magnitude of the S and the S palm. Then the image is 0.5 the size of the object. Okay, so we have the M equal to minus the S palm over the S, right, equal to the plus 0.500. This positive sign, it means that the object and the image, right, just point in the same direction. Okay, so there must be a positive sign here. Okay, then again, we just want to find S and the S palm first, right? So let's find the S and the S palm first. Okay, so let's say that this equation, can we say that the S palm equal to minus 0.500 of the S? Okay, so now let's just put the S palm into this equation. Then we have S, okay, and then plus 0.500 S equal to the 0.600 meter. Okay, because negative S palm here and multiply, sorry, minus sign here and minus sign here is with the positive, right? And we just put it into this one. Then we have the 1.500 times the S equal to the 0.600. Or we can have that the S here just equal to the 0.600 and then over the 1.500, okay, which is equal to 0.400 meter, right? Yep. Okay, so let's be the S. And also we have the S palm. Okay, we have the S palm. Let's use this one. The S palm equal to minus 0.500 times the S. Then it's equal to minus 0.200 meter. Okay, so let's be the S palm here. So you can just check easily if you plug in the S palm and the S into this equation, right? So you get the 0.5, okay? Or if you just put these two into this equation, you can get 0.6 meter. So it's correct. So now the next step is let's find the focal length of this convex mirror. Okay, from equation 1 over the s plus the 1 over the s prime equal to the 1 over the f. 1 over the s, right? The s just equal to the 0.400, and then plus 1 over the s prime. The s prime just negative 0.200 equal to the 1 over the f. Okay. So then again, right, this is not equal to 1 over 0.4 minus 0.2. Okay, so this is wrong. So just be careful about here. Okay, then we need to have the same denominator. Okay, so just multiply by 2, right? We have the 1 minus the 2 and then over 0.400, which is equal to minus the 1 over the 0.400 here, right? So then finally we can get that the focal length is going to be equal to negative 0.400 meter. This is answers. Okay. Okay, so now you can see that this focal length is negative, right? So we say that from the sign convention, if we have the negative focal length, it means that the focal point is going to be the virtual focal point. Okay, and then this virtual focal point is on the opposite side as the reflected ray of the mirror. Okay, for example, in this picture, right, the reflected ray is on the left hand side of the mirror, but the focal point is on the right hand side of the mirror. So that's why we have the virtual focal point here. Okay, if we just want to find the radius of the curvature, right, if we just want to find the radius of the curvature, we just multiply this focal length by 2. Okay, because we say that the focal point just focal length equal to radius of the curvature over 2. So it means that radius of the curvature equal to the 2 and then times the focal length.